Today is Wednesday, October the 9th, 2024. And as I am watching news feeds and contemplating the impact of Hurricane Milton, which is my father's middle name, on Florida, I have to be transparent in saying that I really don't know how I feel about it, because I have warned people over and over that it is inevitable that you will suffer the consequences of the decisions that you make when you ignore the impact of those decisions on other people and the environment. It's as if saying that the earth is dying is some unrealistic prospect that people are unwilling to face, even though all of the evidence is there. It can be corrected and the earth can heal, but people have to be willing to stop what they do individually, which contributes to the overall health of the planet, because the earth is a living, breathing being just like we are. And if you ignore the health of a living being, it will become sick and it will die. Nature gives evidence of that every single day. You cannot continue to do things you know are harmful to the earth, the environment, and people and expect it to survive if you do not stop. As I contemplate what I'd like to share with you today, it seems to me at some point there were engineering students who came up with a solution to direct the impact of storms to try to protect areas that were projected to be hit the hardest, which is a good intention. All innovative engineering is done by kids who have a passion to change the world in the way they believe is needed. The problem is the Department of Defense will then modify those innovations for uses designed to control people and the environment in ways that cause significant harm. These students can't exactly take their work back once the intelligence has been developed, confiscated, and modified. What then happens is that those kids now want to help reverse what they built to try to protect people, which was the initial goal, but they were led to focus on the wrong things for the wrong reasons and could not see or understand the real underlying problems. So the cycle starts all over again. The problem is that people do not know how to communicate with each other. And very often, these engineering students who study various disciplines, all of which have negatively impacted the environment and human physical health, psychological health, and emotional health, overlap. But because they do not talk to each other, it complicates the matter and starts to compound the issue layer upon layer, where they are constantly working against each other. We have to have access to all of the same information at the same time, and we have to be willing and able to communicate with each other to fully see the scope of the problem and what needs to happen in order to cause them to stop. It's not that complicated. Like me, most people have not been aware that geoengineering, geo means earth, has even existed. So I hope this video will enlighten you to how the individuals who have designed this believe it should work and how that should be helpful to the earth and weather patterns. The reality is, not only is this yet another way the government seeks to control, it functions like an immunosuppressant. Immunosuppressants are developed and used to prevent the human body from producing or effectively utilizing its own system of immunity, which is designed to help us adapt in adverse conditions. Immunosuppressants contribute to the development and malignancy of cancer tumors. If you pause for a moment to contemplate what I'm saying, how that works together should make sense to you. Antihistamines are a mild example of an immunosuppressant. You're exposed to something that is aversive to the body and have an allergic reaction. The allergen will not be removed by the individuals who created it and have caused the exposure. So to remain comfortable living in an environment with that type of contaminant, allergy medications are made available to suppress this natural reaction to something the body is rejecting. Over time, the body will then begin to adapt and remain in an adaptive state until the conditions improve. The human body is part of nature and assumes at some point balance will be restored, so adaptations are designed to be temporary. So weather modification of any kind blocks the Earth ecosystem from producing what it needs to heal itself and to then remain healthy. Sometimes the Earth needs to be hydrated to heal a destructive growth, like a dryness on the skin. Sometimes the Earth needs to be dried to heal a destructive growth, like a fungus. Sometimes the Earth needs to organize a complex blend of moisture for the right conditions to heal. But what is being healed is almost always something humans have manufactured, which is not compatible or cooperative with nature, like completely covering the land with asphalt so that the soil cannot breathe. If the Earth's immune system detects it needs a lot of moisture to dissipate something heavily contaminating the air, it makes sense that you could anticipate hurricane-like conditions of water and wind. Does that make sense to you? It's another way the Earth is being ignored as a living, breathing being which is naturally capable of regeneration. The National Oceanic and Atmospheric Administration, which has several offices in Hampton Roads, Virginia, is under the U.S. Department of Commerce, not the Environmental Protection Agency. Does that make sense to you? Remember as you watch these that a cancer is the inability of two or more cells to be able to effectively communicate with each other so that all of the body systems work interdependently. A failure of two or more to communicate.
The UAE is one of the driest countries on Earth, with an annual rainfall of roughly 120 millimeters. As a result, it has to get creative when it comes to finding solutions for water. In the early 2000s, the UAE started performing regular cloud seeding operations. Cloud seeding is the process of increasing the amount of rain produced from clouds.
Some of these clouds, by nature, sometimes it rains, for example, only 40 to 50% of its rain that processed in the cloud that comes as rainfall. So by these operations, we try to increase this amount by, for example, from 15 to 30%.
So how does it work? It starts here, inside the National Center of Meteorology, where a team is constantly monitoring forecasts, looking for potential clouds to seed. The operations only work with cumulus clouds, which are vertical in shape.
Research 5 operation, can you read me?
Once they spot a cloud, they radio the pilots, who then take to the air armed with hydroscopic flares filled with a mixture of potassium chloride, sodium chloride, magnesium, and other materials. It's essentially salt. When the plane reaches the right clouds, the pilots release the flares.
These salts basically attracts the moisture and try to make it condense. So these particles becomes nuclei of condensation, and then when these droplets condense, and then they hit each other, and then they form a bigger droplet that the air cannot hold it any longer in the air, so it forms as rain.
In 2017, the UAE performed 242 cloud seeding operations. The government is confident the operations are increasing the amount of rainfall, but it's difficult to gauge.
Until now, there is no way that you can measure the success rate for each individual cloud. There are no two clouds are the same, and you don't know, for example, before actually you see the cloud, is it going to rain by itself or not, and by how much?
The country has also invested in rain research, offering millions of dollars in grant money to innovative researchers and projects.
You heat up the ionosphere for a few minutes and then you shut it off and you watch the ionosphere repair itself. It does that in a few seconds, and you do a lot of experiments that way, things you can't do in the laboratory.
first time I visited HARP, I didn't even know what it was. I went to HARP as part of a physics club, the Society of Physics Students. I was a student here at the University of Alaska Fairbanks, and HARP at the time held an annual open house event where the public could tour the facility and talk to the scientists.
HARP is a facility to study the ionosphere, region 60 miles out into space. And that's a region where there's not much density. The air is very thin. It's mostly plasma, which means electrons and ions.
When I saw this facility and saw how unique and interesting it was, so when I decided to do my PhD thesis research using the HARP facility itself. HARP stands for the High Frequency Active Auroral Research Program.
The federal government spent about $300 million. It's the most exquisite of its kind in the world. It's currently owned and operated by the Air Force Research Lab. And they have other priorities. They've done some tests over the years. Now they want to go do other things. So it's become a bit of an orphan, sitting down there in Kokona. The U.S. has the lead in the world in this area. It would be a shame to give that up. The other facilities aren't nearly as flexible or as powerful. And HARP can do science that the other two can't. There's a chart that shows, compares all the heaters, including air receiver. You can see that it's quite a bit more powerful and more flexible.
It's an instrument that allows us to make small changes to the ionosphere, and then we can measure the response of the ionosphere and the upper atmosphere to the changes that HARP is making. Scientists have categorized the various layers of the atmosphere. Most of the weather that we experience occurs in the troposphere. When we fly in commercial aircraft, we're generally flying at the top of the troposphere. Above that is the stratosphere, and above that is the mesosphere, and above that is the thermosphere. And the ionosphere is basically part of the thermosphere, which extends from about 80 to 100 kilometers altitude all the way up to about 1,000 kilometers altitude. And so the ionosphere is generally what we refer to as the partially ionized portion of the thermosphere. It's too high for weather balloons and it's too low for many satellites. And sure, we can launch rockets through the ionosphere too, as we do at Poker Flat, but those are very fast but expensive experiments. The reason why we care about the ionosphere, particularly for radio communication, is that radio waves, when traveling through free space, behave differently when they travel through a region of charged particles or plasma. The ionosphere is basically a partially ionized plasma, and so one of the things that can happen to radio waves that travel through a plasma is that they can be bent, their polarization can change, they can be absorbed. And since so much of our lives is really dependent on radio communication, either communicating to satellites or for navigation with GPS, which is also communicating with satellites essentially, or over-the-horizon communication or over-the-horizon radar, it's really important for us to understand how radio waves are affected by the ionosphere, and in some cases how radio waves affect the ionosphere in the case of HARP or other powerful radio transmitters.
A lot of us realize how important it is, how powerful, how significant the facility is. So we're trying to figure out ways to keep it alive as an active scientific tool.
Why would it be beneficial? I can't speak for the applications, but it's a mystery to solve. We can think of the ionosphere as a natural plasma laboratory, the conditions of which are difficult to replicate in an actual physical laboratory. And so this is just another way of learning about the world around us.
Because if the Air Force shuts it down, by prior agreement, they're required to remediate it, which means they have to go back and turn the land back into the way it was before they started. They'll have to bulldoze the whole site away.
We're here in Santa Barbara County, home to one of the longest running cloud seeding operations in the country. We've got some ground-based cloud seeding equipment right here, and we're gonna get to hear all about how it works and see it in action. Let's check it out. Cloud seeding is the most common type of weather modification, and it has many different techniques and applications. Today, it's mostly used to increase rain and snowfall, reduce the size of hail, and reduce fog at airports.
Traditionally, cloud seeding has been done from the air. So airplanes have had racks on them where these same flares are positioned on the airplane, and the airplane flies into the storm. So in order to reduce the cost to the client and reduce our carbon footprint, we've been able to station these on the ground. Now we can do this in places where weather permits.
Behind a barbed wire fence designed to keep away curious cattle, The cloud seeding gear awaits the right kind of weather.
So these are referred to as AHOGs. That stands for Automated High Output Ground Seeding Systems. We've got three primary components of our equipment here. The first is the control module that you see behind me. Then we have our actual cloud seeding flares. The cameras for security. It also helps us observe weather conditions in real time and make sure that all of the equipment is operating correctly during a storm. Inside these canisters are the flares with the seeding agents. The canisters are used as spark arresters, so they prevent sparks from reaching the ground. So if we pull off the spark arrestor, you can see the flare inside. The ignition of the flares are controlled from the control module that's behind us. So the white triangle there is a cell service modem, and then the solar panel keeps us powered. Inside we have a battery and then a control board. So the control board interacts with the software. We're linked or synced with the software in Utah currently, and that allows us to fire or ignite any of the flares from that remote location.
Because of the lack of clouds and proper wind conditions, today is not a good day for cloud seeding at all. But Garrett and his team are going to light a flare for us anyway, so we can show you how it works. There's just one small problem. The battery in the control module died shortly before we arrived, but it's nothing a little jump start can't fix. After a little juice from Garrett's truck, it's time to set off the flare.
The primary seeding agent in this is silver iodide. Silver iodide is a simple compound. It's polar in nature like water, so there's chemical properties that help attract water molecules to silver iodide. It's also structured molecularly similar to ice. So it helps generate or helps spawn the generation of ice buildup, and then that becomes a hailstone or a snowflake that falls here primarily as rain. So one flare like this has billions and billions of potential sites for that water to congregate around. We'll launch them in sequences. We watch the radar to see when bands of the highest concentration of liquid water are passing above us in the clouds, and we try to target those high concentration pockets in the storm systems. We'll launch between 3 and 20 flares for a typical storm. Once the flare is lit, it takes a little bit of time to carry up into the clouds, and once it's up at the proper elevation, it'll take about 20 minutes to instigate the rain or the snow process. So overall, you're probably looking at about 40 to 45 minutes before you're seeing the maximum result. And that's why we're stationed miles away from our target area. So we have very specific targets that drain directly into major water basins, and we time these events to correlate with rain above those intended targets. One of the biggest questions or most common questions that we receive relates to the safety of silver iodide. Silver is biologically inert, so it will not interact in a negative fashion with plant or animal life. Iodine is actually a critical building block of a number of hormones in animals, so it is safe as well. In fact, if you look at table salt or baby formula, you'll see iodine in its molecular form as an additive in those commonly consumed substances.
But what about other potential adverse effects? Could cloud seeding affect communities outside the targeted areas?
Sometimes there is a concern about robbing Peter to pay Paul. So are we benefiting California at the expense of Nevada? And the truth is that storm systems, when they move over off the coastline, only about 10% of that moisture is going to fall in the form of precip. And we're looking at increasing that to about 11% because we have about a 10% increase in the natural storm's productivity. So going from 10% to 11% in California has an insignificant impact on the amount of precip that will still be available in Nevada or Utah.
Built into the program are kind of checks to make sure that we don't come across anything negative. When there are high intensity storms, we won't seed. If the reservoirs are full, we won't seed. If the rivers are flowing a lot, maybe near flood capacity, we won't seed.
We hope that the conditions that exist right now will turn around and that we will not face the severity of droughts that we're facing, particularly this year. But a number of scientific articles are suggesting otherwise. And as we look into the future, we need to again consider conservation first. So the ability for us is to conserve how we use water and the ways that we store the water. And then layer on that efforts like weather modification and cloud seeding to help increase the rainfall that we do receive. It's very important that we take advantage of every opportunity we have to generate water in a sustainable way.
Anybody who's interested in learning more about cloud seeding, I've got links to scientific studies and official reports down in the description.